All right, so this one is very similar. We know that there's a reason why we're going to do this one, and it's based on the other one. So for tangent, let's talk about what tangent looks like. So I'm going to take screenshots just because it looks a little nicer. So if I go to Desmos and I type in tangent, well, let me say this. Sine of x looks like this, right? And then cosine of x looks like this. They're co-functions of each other. What is interesting is that if you take sine of x and you make a composite function, in other words, you take sine of x and divide it by cosine of x, it looks like this. All right, now that's what tangent is. And basically, well, what's going on is there's a number divided by the other number. And so notice that wherever cosine is equal to 0, there is like a vertical asymptote. That's where tangent is not defined, right? In other words, and I'll graph tangent so you can be assured that that's what it is, right? So wherever cosine, my blue graph, is equal to 0, you're going to have a vertical asymptote. And then just the numbers divided by the other numbers, and they both have a range from 0 to 1, but it goes from positive infinity to negative infinity. And then the period, let me clear out a little bit. I'm going to turn this off and we'll just focus on tangent for now. Now the period goes from 0 to pi. So it has a period of pi normally. But all the transformations that we've done before have been the same, okay? So let me zoom in. We'll just do like, we'll make our step pi over 4 in the x direction. So we can kind of see what we're working with. And I'll just kind of zoom in on it. And we'll take a screenshot. So this is just tangent. Oh, I clicked the wrong button. So this is what tangent, oh great, now I gotta wait for that thing to get off. Can I close that? Yeah. I turned on my graphing calculator, but we were not gonna use that one today. Alright, so then tangent looks like this. So let's just kind of keep that in mind. That's kind of what tangent looks like, right? So let me label this so we know. This is what regular tangent looks like. Well, the 1/4 is the a term, right? So the 1/4 still has an impact on the amplitude. But remember, when a is between 0 and 1, it's going to stretch it vertically. All right, so there's that. And then this would be b equals pi over 4. But remember that the period p, now this is where it differs just slightly, is that because the period is pi, it would be pi divided by b. So it's a slight variation. Remember, sine and cosine, their regular period was 2 pi. Okay? So the period on this one would just be pi divided by b, which would be pi divided by pi over 4, which, if you do the math on that, that's the same as pi times the reciprocal of pi over 4, which is 4 over pi. The pi's cancel, and I get a period of 4. Okay? So now, and then it goes, and then it's no accident they say graph it from 0 to 8. Notice that that's 4 times 2. So we're going to get 2 periods. We like to get 2 periods when we do a graph. Okay? So let's go into Desmos and plug all this in. So I'm going to put a 1/4, and I'm doing it this way specifically so you can see the transformation. So in the front, when I go 1 divided by 4, oh, I'm sorry, it would compress it. I said stretch, but I meant to say compress. So that compresses it. Stretches when it's greater than 1. Sorry, I misspoke. It's not easy doing this every day. So we're gonna now when I put the 1/4 in there, that's gonna change the period. So you're gonna see big gaps. So this is gonna move all the way to 4. So what I'm gonna do is I'm gonna change this real quick, and we'll make the step 1, and I'm gonna go from 0 to 8 because that's what it said. Actually, I'll go from 0 to 9. I'll go from -1 to 9 so we can fit it in. Okay. All right. And so then when I put this pi over 4, pi divided by 4, that's it, right? So that is the graph. And we'll just label that so you can see. So this is y equals 1/4 tangent pi over 4. Okay. I'm going to jump into example number 2 real quick. Does everybody have that kind of sketched out roughly or no? Should I wait a second? I'll wait a second. Just let me know. I don't want to keep going. How about now? How about now? We need a signal. Good? All right. So let's do the next one. Now the next one is basically the same thing, but it's cotangent. Now remember that cotangent of x is equal to 1 over tangent of x. Now, here's what you may not know is that when the reciprocals of trig functions, you're basically just flipping them. So this should be, and I'm going to do it in just a second, but everything's still the same, right? So a would still be 1 over 4. That compresses it. Whoops, that's not an arrow. That compresses it vertically. B is pi over 4, and when we do the math on that, the period will be 4. So that's the transformation. But cotangent, when the reciprocals of these, you're kind of, I don't want to say you're flipping it, but you kind of are. So when I come in here, watch what happens to this graph when I change this from tangent to cotangent. Same exact thing. But because you're flipping it, you're really doing cosine over sine. So now sine is on the bottom. In other words, when I say sine, we say cosine divided by sine of x. That's that black line. Let me turn some of these off. It's probably confusing. But notice that when sine equals 0, that's where you're going to have your vertical asymptote. So it does shift over a little bit too. So we kind of flip it, and it does shift over a little bit. Because they're the same numbers that are being recycled, they're just being recycled in a reciprocal order, right? We're just going from -1 to 1, and that's where everything comes from. And so when I change that to cotangent, it shifts over slightly, but it's basically the same graph. Okay, so let's just go ahead and copy that and kind of sketch that into our okay. I'll give you guys a second to write that down. The period is still 4 though, because the cycle, if you notice that the x-intercept is here at 2, let me make this a little bigger too so you guys can see it. The x-intercept is 2 and the next intercept occurs at 6, which is 4 units away. Okay. And a very similar thing happens with cosine. Remember that secant of x is equal to 1 over cosine of x. And since we're experts now in the transformation of cosine, I know that the amplitude would be 1/2. It's less than 1, so that will vertically compress it. I know that b is equal to 2. I know that my period p, because this is the reciprocal of cosine, it'll be 2 pi over b, which is 2 pi divided by 2, or just pi. So if I were to sketch cosine of this bad boy, the amplitude would be 1/2. No vertical shifts or anything like that. Well, that's not the best line, but you guys get the gist, right? And so it's going to go from, because it's cosine goes like this. And that would be pi. And I'll do this on Desmos in a second too, so you could see it like a lot better than my rough sketch. Okay, so let's do that on Desmos real quick. So if I go in here and I do 1/2, watch what happens to regular cosine. So there's regular cosine. When I do 1/2, it changes the amplitude, right? And then when I put 2 in front of the x, 2 times x, the period is pi, right? So if I change my settings here and I go from, I don't know, we'll do 1/2 pi, 1/4 pi. So from here to here is pi. 1 whole period is pi. And I think if we look, it says go from 0 to pi. So they just want us to do 1 whole thing. But this is cosine, right? So I'm going to take a screenshot of this so you guys can kind of see that it's cosine. And then we're going to compare that to secant. So secant is just going to be, I don't want to say you flip it, but I can't think of a better word than to say to flip it. So that's a better rendering of 1/2 cosine of 2x. But now watch what happens, and I'm going to graph it on top of all this. So if I say 1/2 secant, 1/2 secant of 2x, it just kind of flips it. Now notice, and this has to do with cosine, notice that when cosine is equal to 0, you have a vertical asymptote, right? Because secant in reality is 1 over cosine, right? So this is like 1 over cosine, and so 1 over cosine is secant, and wherever cosine equals 0 is where you're going to run into this thing. So if wherever my transformed cosine equals 0, you're going to have a vertical asymptote, right? So if I turn this off, this is the graph we're looking for. So if you ever had to graph this, and so when Mr. Adams had to do this, back in my day, when Mr. Adams had to do this, we used to do this by hand. So what we would do is we would graph cosine, and then however cosine graphed, we just draw like a U above the cosine, which is still helpful. Why is that not copying? Are you guys having problems with your internet? I'm going to try and line that up. So you could see that, and let me write this in. This would be 1/2 secant of 2x. And we're almost done. I'm gonna get to example number 4, and then we'll call it quits. So that's how you would graph that. But at the end of the day, when you go to do your homework, you just plug it into Desmos. But I do want you to think about what do these numbers do and how does it transform the function. Okay, and then you'll think, oh well, it'll compress it, it'll stretch it, it'll shift it, it'll do all these things. Okay, can I move on to the next one? Okay. Same thing for cosecant. Remember that cosecant of x is the reciprocal of sine. And so I'm going to sketch this one by hand. Again, we have a equals 1/4. Because it's a fraction and it's positive, that's going to compress it vertically. We see that b is equal to pi over 4. Because this is the reciprocal of sine, remember that the period of sine is 2 pi. And then we're going to divide that by b, which is 2 pi divided by pi over 4. Remember, that's the same as multiplying by the reciprocal, which is 4 over pi. The pi's will cancel, and we're left with just 8. So the period is 8. So now, if I were to graph this, and I'm going to sketch it, and then we'll do it in Desmos. You start with sine first. So sine would look like this. It would go from positive 1/4 to negative 1/4. And it would have a period from 0 to 8. So I'm going to sketch sine. So this would go like this. I would go up and down and back. Then in the opposite direction, up, down, and back. And so that graph right there is y equals 1/4 sine pi over 4 x. Now, to graph this by hand, what I'm going to do is I'm going to say, well, look, wherever sine is equal to 0, there's a vertical asymptote. So sine is equal to 0 here, vertical asymptote. Sine is equal to 0 here, vertical asymptote. Vertical asymptote. I'm extending it so you can see it. Vertical asymptote. Vertical asymptote. So then to graph cosecant, it's just going to kind of do this. And that would be y equals 1/4 cosecant pi over 4x. Let's see. So we're going to say 1/4. Oh, hey, look, all I got to do is put in cosecant here, right? Oh, I got to show it, though. And let's label this, too. I'm going to change. We're going to count by 1 instead of pi over 4. Because we said our period was from, well, what did we say our period was? 8, right? Yeah, I had it right. The only thing I didn't do, I didn't, but it's really difficult to draw. So that's essentially it. Any questions on that? And I'd have to like zoom in. So if I like zoom in, when I zoom in, you could see that that's like 1/4, right? Like you could see it gets pretty darn close to 1/4. Actually touches 1/4. And if I zoom in over here, it goes to negative 1/4. Okay. All right, let's do these last two example problems. Now the only difference here, and I'm just going to graph these, we know what this does when we pull out B and we do the C over B, and we know all that. We know this is going to be a vertical shift. We know this is going to flip it. But at the end of the day, we could just graph it, right? So I'm going to clear all these out. I could almost sketch in my head what this would look like. It's going to be cotangent. So it would be tangent but flipped over and shifted over. Then this is going to transform the period of it and shift it and compress it. And then also I'm going to shift it up once, or up 1 unit. So we're just going to graph it real quick. So that was 1 minus cotangent, what was it again? Pi over 4, pi over 4x, whoops, over 4x minus pi over 2. Minus pi divided by 2. Close my parentheses. Whoops. Okay. And I'm going to zoom out here. And so it looks like I have a period of 4. And I mean, that's basically it. And it shifted up because, I know it shifted up by 1 because this point right here, where y equals 1 is, this is what we call a point of inflection, but that's where the that's where the curve goes from curving down to curving up, which is this area right here would normally be on the x-axis. Does that make sense? Okay. So we'll just take a snapshot of this. And that's what it looks like. And then lastly, we'll do number 6. So I'll give you a second there to kind of sketch this out. But I guess we could label it too. We could say that A equals -1. That flips it. So if you notice, that looks like tangent, doesn't it? Well, maybe not. Maybe you haven't memorized these graphs yet. But it looks like tangent. Remember, cotangent is like a flip of tangent. But because A equals -1, we flip cotangent, which makes it look like tangent. K is +1, so it shifts it up 1 unit. We got to do the BC thing, right? So we know that B is equal to pi over 4. And then we know that C is equal to -pi over 2. So then C over B, which does like the compression thing, or stretches it horizontally, because it's positive, that's going to flip it this way, right? It's going to flip the graph this way. So it flips it horizontally. But let's do the math. We say -pi over 2 divided by pi over 4. That's the same as saying -pi over 2 times the reciprocal, which is 4 over pi. The pi's cancel. We've got -4 over 2. So this is just -2, right? So that does like the compression stretchy thing, but because it's negative, it'll flip it too. And then the period, remember that the period is just pi over b. And so you would have pi over 4. And if you do the math on that, it's just 4. And that's what we figured out in the graph, right? This was like 3, 0. This was like 7, 0. That's a period of 4. One last one. I don't want to go too fast. I'm just trying to get them all done. Any questions? All right. This next one, same thing. Does everybody have everything written down, or do I need to wait a second? Okay. Same thing here. We just plug it in, right? So I'm going to change this to 2. I'm going to change this to, what was it, cosecant? Pi over 2x, pi over 2x. And I think this is a 4. Minus pi over 4. Is that right? Yeah. Was it secant? Secant. And let me just sketch this in there real quick.